Well, that first spot the mistakes video seemed to go down reasonably well, so I've done another one. This time it's for the electrophilic substitution mechanism, and I've gone for the mononitration of benzene. So I'm sure you've done that quite a lot in your organic chemistry studies. So have a look at the mechanisms I've drawn. There's mistakes in all but one of them. So see how many you can spot in each one, and then play the video for the answers. Okay, so A, the first mistakes there, they've forgotten to put the minus charge on the HSO4 minus ion. The second mistake is the origin of that curly arrow there. It should start at the delocalized ring of pi electrons. So there's a mistake there. And the third mistake is they've forgotten to include the H+. Remember, when this comes off, forms an H+ ion. Mechanism B, the first equation's fine. The mistake they've made, they've actually repeated it. So you can either count this as one or two mistakes. It's the connectivity of the nitro group. So the nitro group is bonded via the nitrogen and not via that oxygen. So they've kind of repeated that mistake there. And the other mistake they've done is they've forgotten the H. It's HSO4 minus as in there. Mechanism C now, this is pretty bad because they've forgotten both of those charges. It's NO2 plus HSO4 minus. Oddly, they've remembered them there and there. Next mistake, we've already seen this one, is the origin of that curly arrow. Remember, it's got to come from the delocalized ring of pi electrons. It's got to come from the circle. Next mistake, they've forgotten the charge in the intermediate. It's got to be positively charged. The next mistake is the origin of that curly arrow. It's got to come from the bond. So I always say to students, take it from the middle of the bond back into the ring. Next mistake, they've forgotten that charge there. Final equation's okay. I always feel a bit bad for students for the kind of mistake you see in D. There's only one mistake, and it is the way they've drawn that partial delocalized ring of pi electrons. Possibly down to the fact that they always substitute at the 12 o'clock position. This substitution's happened sort of at the 1 o'clock position, so this should be open there. Everything else absolutely fine. Moving on to E, this is absolutely perfect, so we'll give that the smiley face and move on to the final one, F. So there's a total of 2 mistakes in this one, and it's down to the curly arrows they've drawn. So the first equation's fine. You can see this curly arrow is going in the wrong direction. It has to start at the delocalized ring of pi electrons, comes out to the N. And the other mistake is in the other curly arrow. It's going again in the wrong direction. It needs to come from ideally the middle of that bond back into the middle. Everything else is fine, it's just those 2 curly arrows, so 2 mistakes there. Okay, that's it. Hope that was helpful.